Can everyone hear me well? If you guys can hear me, please raise your hands for me to know that uh, you can hear me clearly. All right. Thank you so much. Today, I am hosting this webinar to discuss about, to present about what actually happened when you use the 4G connectivity in practice for some BVLOS mission, where it fails, and how to build a link that keeps the pilot in control when the bandwidth drop in mission. So the focus application for today is related to the ISR, which is the intelligence, surveillance, and reconnaissance. So the reason why I choose ISR to be the focus, because this is the application that has a really strict requirements, especially with the connectivity infrastructure. So it will require, for example, like long range flights, continuity, real time. So if we can solve the problem in the ISR sector, we can actually apply with the same method for the other sector. All right. So today I will have the presentation to share my screen. Okay, so today's content will cover four main parts. First one is the market context of the drones in UAVs market in the 2026. The second part is the real ISR operations. And third one is the connectivity safety and the adaptive migrate technology. And the last one, we will have a a short flight demo. And we actually flight in our area. So let's get into the first part. Okay, so uh, let's get into the trend of the BVLOS and also the regulational framework in 2026. So the drone market in 2026 is expected to reach around $31 billion. And the BVLOS missions take more than 60% of the total industrial flight time. So as you can see, BVLOS is no longer an experimental, but is becoming the new operational standard. Many organizations are gradually moving beyond the trial flights, and they start to transition toward the larger scale to routine BVLOS operation. And the gap between these two groups is decided by only one factor, which is the connectivity structure. So here is the actually the regulational frameworks. In here we have in America, for example, we have the FAA Part 108. It's getting into complete, so it will allow BVLOS without needing to, get some waivers permission, which previously take around 3 to 6 months. And also in Europe, there are also the ESH U-Space framework. They are now in effect. So it will enable the organizations to establish dedicated BVLOS operation zones, and they can conduct routine and recurring operation. So these two regulational frameworks set some specific requirement related to the technical, the high quality data link, and those are the things that the traditional radio frequency connection cannot adapt. So there are two issues that I want to mention right here. The first problem is the limitation of the radio frequency. So as you know that the radio frequency is getting blocked by the terrains, the buildings, some mountains and the Fresnel zones. For someone who is unfamiliar with the word Fresnel zone, is the area surrounding the direct line of sight path between the transmitter and the receiver. So even when there's a clear visual line of sight objects, such as trees, buildings, or terrain that intrude into the Fresnel zone, can cause signal reflection, diffraction, and it will reduce the RF link performance. So yeah, as soon as the drones fly beyond the RF coverage area, the signal is lost. So in many cases, many organizations are forced to deploy multiple crews in the field, so they can follow the drone, and then they can maintain the line of sight communication, as you can see in this diagram. So the result is they lead to a high cost for the manpower and the logistic. So they can lose the benefits of the drone automation. The second problem is the instability of the cellular network at the field. According to GSMA, the high quality coverage in the offshore areas, in the borderline, in the industrial zones, only under 45%. So when the drone get into the low signal zones, the bandwidth drops, and with the normal device, the HD, the high quality video stream takes all of the data link pipeline. So it will lead to some following consequences. First is the C2 links get dropped, like the command and control link. Secondly, it's the video's latency increase very high. Third is the pilot. He lost the situational awareness, and the worst thing is the drone automatically trigger return to landing, so the mission failed. Right. So this is the reason why XBStation create the XBLink series. So to actually solve the problem that radio frequency cannot solve in the ISR sector. Right. So we will come to the ISR use cases. So it will require the beyond the radio frequency area limitation. So firstly, I want to mention some some common scenario in the ISR, in the practical ISR. The first thing is, for example, you got the borderline security. So there's a unit they need to have an inspection, for example, like 20 kilometers in the borderline. The drone will attach the thermal cameras, and it needs to stream the videos to the ground station. So it required, for example, the pilot must sit in the office, no need people on the field, and stream videos continuously in the real time. Or maybe another scenario is the buildings or the pipeline inspection. For example, an oil and gas company need to inspect a pipeline, for example, like 30 kilometers across the forest. So the drone will attach the camera with the the pan tilt zoom. It flies across the corridor, and it will detect leaks or infrastructure damage, and it will record the precise GPS location for maintenance and teams to investigate and respond. So you can see that why the radio frequency fails here. The reason why the radio frequency fails here is the drone can only fly in the line of sight range. So according to our experience, it will be about 5 kilometers before it's lost the signal. So to be able to operate in 20 kilometers inspection, enterprises must choose one of among these three options. So I will get one of the three options for you right here. So the first option that they might think about is to establish multiple launch sites along the route. The second option could be deploy the radio frequency relay station, or the third option is deploy the station staff throughout the flight corridor. So when people use the drone, they expect to achieve some benefits, but those three options actually break the core advantage of the drones, which are automation and reduce the manpower costs and requirements. Right. So the consequences is the RF radio cannot adapt with the BVLOS operation. So what we have in our operation is that we can use the 4G or 5G or the satellite, for example, like Starlink, to work in parallel with the radio frequency to be the backbone of the data link transmission in the offshore drone operations. All right. So among those three options, we will choose the 4G to be the topic of the presentation today. So in XBLink, we have the XBLink 4G R2. So for example, the features right here. So for example, you have the drone to fly like 20 kilometers via 4G. So you don't have to move the landing or the takeoff places. You can attach many type of thermal cameras or many IP camera through the Ethernet port, right? And it can stream with the high quality. It can be also plug and place with many type of camera. All the data is AES 256 encoded. And also when it get into the low signal zones, the ABR, which is the adaptive bitrate function of our XBLink, will automatically reduce the video quality and will prioritize this command and controlling. So the pilot will never lose the control of the drone, and they can sit in the station or the office like 20 or 30 kilometers far from the field, but they can also have a full control of the drone. So yeah, you will only need one person sitting at the field to control via 4G network. Okay. So here are some key benefits that I've just mentioned. So you have less personnel in the field, for example. They can reduce the cost for deploying those kind of operation. They can also conduct continuous like 24/7 monitoring with no signal blind spots, and they will optimize the cost and the ROI. Okay. Okay, so I've just mentioned about our XBLink 4G R2, but what actually inside the XBLink 4G? So we will get into it right now. Okay, so XBLink 4G, for some people who haven't heard about it, it is a companion computer of XBStation. So it will be attached on the drone to add another connectivity layers. So for example, you already have the radio frequency. You can add another like 4G connectivity, so it will go in parallels. Here are some specifications. So all of the XBLink series are weighted under 100 grams. So for example, like the XBLink 4G right here is 96.6 grams. So it's light enough to attach on almost the airframes in the market right now without affecting to the payload capacity or the flight time. The dimension right here is also have a compact form, so it can be integrated into the some urban ISR drones, some common ISR drones in the urban area. And the voltage it takes directly from the drone, so no need to additional resources. And also the temperature of the devices is around -10 Celsius to 60 Celsius. So it will suitable with the fields from the cold mountain to the tropical industrial site. Okay, I will walk you through some of the ports, and I think that this slide is quite important. So we have the UART to connect directly with the flight controller. We have the Ethernet port to integrate with many type of camera, some thermal cameras or the pan-tilt camera. There are also some two USB ports and the MN6 to get the antennas. Next is the transparent MAV link bridge. So this is the architecture that we want to mention right here. XBLink 4G R2 is not the just the modem or the USB. It's a companion computer. So the line of the action is XBLink connect to the flight controller through the UART port. So it will receive the MAV link and it will be encoded to the cellular network, and then get into the XB cloud. So it will decode it. It will be decoded and then continue to the ground control station. So the mission controller or the Q ground control station can see the drone via the internet, like when you connect directly to the flight controller. So no need for complex setup or integration, because this is a plug and play solution. And also there are some there are some additional features. First is the stream sharing. So you can easily understand it as creating a link, and then you can send to other people so they can watch the live drone video stream on their browsers. And there's the architecture that I want to mention is the dual link. So the architecture of this setup is the radio frequency and the cellular network. So when you can control your drone with the radio frequency in the short range, and when your drone getting out of the range, it can easily switch to the 4G. So it will allow you to fly beyond the visual line of sight. Okay, so there are some questions that we received when we introduced about this our product. So what if the network drops? Will the person or the pilot lose the drone? So for the core problem right here is the full high quality video might require some higher bandwidth, but the network conditions are not always in ideal condition, right? So in the weak coverage areas, some available bandwidth can fall. So without the intelligent traffic management, the video stream continues attempt to push the data through the constrained link. So it will cause the network congestion, and it will lead to the command and control and telemetry packets become delayed in the transmission queue. So it will potentially leading to the loss of communication with the drones. But in the XB firm, inside the XBLink, we have the 4G R2 run the XB firm. So it will not simply just transmit data, but it can also have a intelligent function to prioritize the critical data. So when it detect to when it see the decrease in the bandwidth, it will conduct two action immediately. The first action is to compress the video, so it will reduce the resolution and the frame rate to the minimum, so it will enough to maintain that the moving frames, right? The second action is to prioritize the command and control link, so it will spend the rest of the bandwidth to the data transmission, to the control and telemetry. So the videos can have a a low quality, but the control of the drone will be completely inside the pilot, so they will maintain the control in most of the cases. Yeah, so that's it that we are ready to have a low quality video, but we never leave the pilot lost the control of the drone. So this is the borderline between a normal data transmission devices compared to a system is designed to for the enterprise operation, right? So I hope that that's enough the theoretical information for you today. So we will go to the part that myself also exciting the most, which is the live videos, live stream. All right, so I will switch the screen right here. Okay, so at this moment I'm sitting at my office. So the drone is put it is places far from, for example, like 3 kilometers, around 3 to 4 kilometers, and we will share the screen directly to for you in this meeting. So this setup is close to the practical setup of the ISR. So I will sit at the office. For example, another pilot is in the field with the radio frequency backup. So it will be the same with the practical process of operating an ISR cruise. So all of the demos is designed to answer one question: if this was a real mission, the operator, what do the operator do? What will they see, and how the system reacts, right? So we aim to the aircraft, and we take off from the ground control station. Yeah, and the drone is now getting into the mission altitude, and it begins to follow the predefined waypoint routes. So you can see right here. Okay, so our drone will get you through around the Da Nang city. So I'm actually introducing Da Nang city to you as well. So if any of you have a chance to go to our city, please have a look at this. So in here we have the beach. Actually, our office is near the beach as well. Okay, so to help you get a more a more practical view, I'm gonna do the stream sharing function, the stream sharing features that I've just mentioned before. Okay, so guys, please read your chat box. I will leave you a link right here. Okay, so have you seen the link in the box in the chat box? You can click in that link, and then you can play to see if you can see the actual stream videos from our drones. I will also open in my browser. Okay, guys, can you see the video? If yes, please let me know in the chat box. Yeah, so I guess that everybody is okay, right? All right, so the stream sharing features basically is the kind of features that very important. For example, you have many stakeholders who want to also monitor the the flight routes. So they will also can easily join via the browsers, right? If anyone gets some some pause in your video stream, please reload it. And so for this XBLink 4G R2, you can also use it with many types of cameras. For example, for some mission which required for the thermal cameras, you can also use it. Okay. Okay, guys, please let me know if your videos going well. If you can see what we see, you can just simply raise your hand or something that just to let me know. Okay. All right. So that's the demo. So I hope that it can give you a clear view of the features, that the stream sharing features of our site, and also what is actually the views of the pilot when they use the XBLink 4G to control the drone beyond the visual line of sight. After this presentation, I have like three takeaways right here. So first thing is that the BVLOS is now be ready to be applied, and it is necessary at this moment. For example, like Part 108 is open the door for the BVLOS operation without waiver permission. So the enterprises who choose the right device and the process today will be the very first person to operate, so they will not have to wait. The second is the safety is the first priority. So with the dual link architecture, with the radio frequency plus cellular network, or even the satellite network, the encoded AES 256 and the adaptive byte rates, which prioritize the command and controlling, will always ensure that the drone is in a safe condition, even when in the low coverage areas, low signal areas. And the third one for the XBLink 4G is you don't need to change the current workflow. The XBLink 4G is the transparent bridge, a plug and play solution. So you will not have to replace any ground control station platform. No need for customization, or no need to have a restructure in the pilot team. Okay, so that's pretty much our presentation for today. I hope that the information that inside this webinar can help you somehow have a clearer view of the ISR mission and how is the BB operation look like. So I would just leave a Q&A session right here. So if there's any question that you might have in during this webinar, please leave it in the box chat, and we will answer question by question. I got a question related to the end-to-end videos delayed. So it will be about around 50 millisecond. We got one question about the pricing. So for the pricing, it will be nine for the XBLink 4G R2. It will be $925. Plus, we will have a 6 month of free subscription, and after that, there will be another fee for the subscription as well. Hi, Coffee. I saw you raise your hand. Uh, Hi, Coffee. I hear you. So, for the subscription, you're starting from $79 for monthly. For quarterly, it will be $149, and for the yearly, it will be $249. Sorry, for yearly, it will be $549. Okay, for the question of the drone developers, so how can you integrate this XBLink to your VTOL, and how much space do you need? How many connectors? So for this question, I will send you our specification sheet to your email after this meeting, after this webinar. Hi, Kofi. I saw you asking about the setup walkthrough. So, if you already purchased, we will have our engineer team to have a clear instruction, the initial integration setup to support you in your integration phase. I saw a question from Hawks. Okay. Yes, you can stream and control the gimbal payload via the 4G. So after purchasing, you can share with us what camera type that you are using, so we can check and we can have the integration of it, especially when they have a gimbal control features. Sorry. Okay. For the altitude, I received a question from Fawn about the lose how high can a unit go without losing the connection. So, is expected to the signal to be weakened at around 200 to 500 heights for the 4G network. So it also depends on the cell coverage infrastructure. So from our side, we also test with the 500 meters height, but up to that altitude, the signal is getting lower. Uh, for the question from Kofi, what's the difference in this setup compared to the Starlink type? So for the Starlink, you may need a Starlink antennas attached to your drone, and then you can connect it with the XBLink. But for the 4G, you only need a SIM card to input it in the device. So for the Starlink, you need to have an a drone that is big enough to carry a Starlink dish. Related to the dual architecture. So for the dual architecture, what I mentioned right here is, for example, you already have the drone that you control via the radio frequency, right? So our device is not actually replace that current setup, but it add another layer. So you can imagine that you can control the drone with the radio frequency in the short range, and then when it go out of the radio frequency range, it can switch to the 4G. So you can set up two people, one they hold the controller, and one they sit in the office to also control via 4G network. Yeah, so that's the dual link. So it can work in parallel, and there will be the seamless switch from RF to 4G or 4G to RF. For the question in with the Starlink, how to get the power for Starlink. So you can get the resource for Starlink through another module. So we only connect to Starlink Mini via the RJ45 port to get the internet. For the system on the autonomous boats or the river or sea, so for boats, as long as it runs autopilot or pace 4, it can also use with the boats as well. So not only drones and UAVs, but also the boats and rovers. For XBLink satellites, we start to shift it. We shift it to the NDAA version, which there's no Chinese components. For the current stock, we only have the mini version, 4G, and the satellite XBLink Sat NDAA in stock. The 5G will be restocked after like 3 or 4 weeks. For the XBLink sats, we do not provide the satellite services. For the Starlink Mini, for example, our clients usually work with the provider for their for their own subscription and the Starlink dish. Kofi, for the power of the Starlink, I think that we can set up another meeting after this, so we can bring our engineer team to support you in detail, and we share you more information about the power module. Right. Okay. I think that if after this webinar, if there's any question, please reach us via email. And also, I have a special gift for anyone who joined this webinar with us. So for the first XBLink order that you make after this meeting, we can give you a 10% of discount. So I would just type the code in this chat box. All right. So when you make your first order after this webinar, you can just use this code and share it with us. So you can tell with us that you attended the webinar, the first webinar right here. So we will share the discount of the 10% for your first order. All right. Thank you so much for joining our webinar today. I hope that the session today can bring you some useful information, either is related to the BVLOS operation or any other concern that you might think about when you use our product. So we will also have host this webinar monthly. So I hope that we can also meet again in next month, and the next month topic will be different. Each month will be different, and I hope that you would be the follower of our like monthly event like this. So thank you so much for joining, and I hope you have a great day.